Solving exponential and logarithmic equations, a review. Let's just get started. We have 2 to the 5x equals 4 to the 2x minus 1. In this particular problem, it's actually an easy problem because we can rewrite the bases so that they have the same base. So this is 2 to the 5x, and then I'm going to change 4 to be 2 squared to the 2x minus 1. And remember, when you have a power raised to a power, you're going to multiply, which means I'm going to have to distribute. So I have 2 to the 5x equals 2 to the 4x minus 2. And then if you have this situation where the bases are the same, then the exponents must be equal to each other. So I have 5x equals 4x minus 2. I'll subtract the 4x, x equals negative 2. Number 2, we have 2 times 3 to the 2t minus 5 minus 4 equals 11. What I want to do first is isolate the exponential expression. So I'm going to add the 4 first. So I have 2 times 3 to the 2t minus 5 equals 15. I'll divide by 2. So 3 to the 2t minus 5 equals 15 halves. And now, obviously I can't write these like I did in the previous problem to have the same base. So I'm going to use a logarithm. So the logarithm, I'm going to use log base 3. We can do like an undoing the swirl like I did in the previous lesson, of the 15 halves equals 2t minus 5. So log base 3 of 15 halves, that's going to be a decimal, and I get that from my calculator, but I'm going to do that at the very end. I know that to isolate the t, I'm going to need to add the 5, so I'm going to have log base 3 of 15 halves plus 5 is equal to 2t, so that really means I'm going to have a half times log base 3, 15 halves, plus 5 equals t. I type all that into my calculator, and I'm going to get about 3.42. approximately. Number 3, same thing here. I want to isolate the exponential expression. So I'm going to have 4e to the 2x is equal to 5. And I'll divide by the 4. So e to the 2x equals 5/4. So I'm going to have to use a logarithm again. Since my base is e, I need to do a natural logarithm. So it's going to be the natural log of 5/4 equals 2x. So natural log of 5/4, I'll get that from my calculator, and then I'll divide it by 2. So really you're going to have a half times natural log of 5/4 equals x, and when I type that into my calculator, I'm going to get about 0.11. All right, now we have logarithmic equations, and we're going to switch these over to exponents to solve them. So with this first one, I'm just going to go ahead and do the swirl. So I'm going to have this base of 5 raised to that power is equal to 3x plus 2. So 5 squared equals 3x. I said plus 2, I meant plus 1. And then I just solve. So that's really 25 equals 3x plus 1. 24 equals 3x, so x equals 8. On the number 5, we have to, again, isolate the logarithmic expression first. So I'm going to subtract the 4. So I'm going to have 2 times the natural log of x is equal to negative 1. I'll divide by a half. So I'll divide by 2. So that's negative 1/2 equals natural log of x. And then again, I'm going to do the swirl. So e to the negative 1/2 is equal to x. So e to the negative 1/2, that's actually 1 over the square root of e if you want the exact value. The approximate value, you can just type that into your calculator, and you're going to get about 0.61. Number 6, in this situation, this is actually a nice easy problem as well, because if you have log of one base of some quantity equals log of the same base of a different quantity, then those two quantities have to equal to each other. We saw that in one of the properties that we talked about in the last lesson. So I'm just going to say 3x is equal to 4x minus x squared. So this is a quadratic. I'm going to add the x squared to this side over here, and I'll subtract the 4x. So I have x squared minus x is equal to 0. Take out the greatest common factor. That's x times x minus 1 equals 0. So x equals 0 and x equals 1. Now, one thing that you have to be careful about with logarithmic equations, and I should have mentioned it back here, is that you have to check your answers. And you don't have to write down what it is that you're checking, but you just have to remember that whatever goes inside of the logarithm has to be a positive quantity. So if you put the 8 in here for x, then that's going to be 8 times a 3, which is 24 plus a 1. So that's the 25, and that's okay. Same thing here, plugging a 0.61 inside of a natural logarithm, that's totally fine. But here, if I take one of these answers like the 0 and I try to plug it in for x, then I'm going to be doing log of 0. And that's not a thing. Because remember, if I'm trying to say log base 4 of 0, then that really means 4 to what power is equal to 0. And there's nothing that makes that true. That's just nonsensical. So that means that x equals 0 is actually not an answer. And just quickly checking with the 1, if I plug in a 1 up here, I'd be looking at log base 4 of 3, which is just fine. And then over here, if I plug in a 1, I'm going to have 4 minus 1, which is 3, so that's also fine. So the only answer is just x equals 1. Number 7, what we're going to have to do on this one, because I have log of a quantity plus log of another quantity equals 2 times log of x. I'm going to condense these two expressions first using the product property. So I will have natural log of x minus 2 times 2x plus 3. And then on the other side, let's move that 2 up as an exponent and call that natural log of x squared. So on the left-hand side, let's multiply that out. We're going to have 2x squared minus x minus 6 equals natural log of x squared. And now, like in the previous problem, those logs basically just disappear. So I have 2x squared minus x minus 6 is equal to x squared. I'm going to subtract this x squared over here. So I'm going to have x squared minus x minus 6 is equal to 0. That easily factors as x minus 3 times x plus 2. So I'm going to get x equals 3 and x equals negative 2. But I need to check those answers before I determine that they're both a solution. So if I check the 3, if I plug in a 3 into that first expression, that's going to be 3 minus 1, which is positive, that's okay. If I plug in a 3 here, that's going to be 6 plus 3, which is 9, that's okay. And obviously here, plugging in a 3 is good as well. If I check the negative 2, that's going to give me a negative 4 plugging into that logarithm, and that's not okay. We can't plug a negative quantity inside of a logarithm, so negative 2 is not an answer. The only answer is 3. Before we go on, I do want to mention that you only have to check for extraneous solutions if it's a logarithmic equation. So when you get an answer that doesn't work, that's called an extraneous solution. And you only have to check those in a logarithmic equation. So we had to do it for number 6. I should have checked for numbers 4 and 5. But back here, these were exponential equations, and you're not going to end up with extraneous solutions in exponential equations, so you don't need to check those. I mean, you can check these, and you're just going to find that they all work. Okay, so you only have to check extraneous solutions in a log equation. Okay, here's our last one. Similar to the previous problem, I'm going to condense these, but this time I'm going to use the quotient property because it's subtraction. So I'm going to have log base 2 of x plus 3 divided by x minus 3, and that's equal to 2. So we don't have log of a quantity equals log of a quantity like I did in the previous two problems. So what I'm actually going to do here is I'm going to do the swirl. So I'm going to have that this base, so this power is equal to that expression. So 2 to the second power is equal to x plus 3 over x minus 3. So that's really just 4 equals x plus 3 over x minus 3. I'm going to cross multiply. I'm going to subtract the x. And I'm also going to add the 12. And I'm going to get x equals 5. So let's just check it to make sure that it works. So if I plug the 5 into the first expression up here, that's going to be 5 plus 3, which is 8. That's okay. If I plug it here, that's going to be 5 minus 3, which is 2, and that's okay as well. So it works.